Hi everyone, welcome to Naming of Organic Compounds tutorial. My name is Dr. Teresa Chimambam. So we will start with alkanes. First, you are asked to draw the structures for the following compounds. I is 2-methylpropane. So for you to draw this compound, you need to remember that propane is an alkane and that it has 3 carbon atoms. So the longest carbon chain will have 3 carbon atoms, and then you complete the hydrogen atoms, and then you also need to take into account that you are asked to draw 2-methylpropane. So 2 means that methyl is in the second carbon atom. So if you number it, this is 1, 2, 3. So you put your methyl here. So this is the structure of 2-methylpropane. So III is 2,3-dimethyl-pentane. So pentane is the longest carbon chain, and pentane is 5 carbon atoms. So you draw 5 carbon atoms and add the required number of hydrogen atoms, bearing in mind that carbon can only have 4 bonds. Carbon is tetravalent. So you are asked to draw 2,3-dimethylpentane. So it means that there is a methyl group in the second carbon atom and there is another methyl group in the third carbon atom. So if you number it from left, this is 1, 2, 3, 4, 5. So this is 2,3-dimethylpentane. III is to draw 3-ethyl-2,4-dimethylhexane. So hexane is the longest carbon chain, so 6 carbon atoms. So we draw 6 carbon atoms and add the hydrogen atoms, and then we are asked to draw 3-ethyl. So we put ethyl group in the third carbon atom, and then 2,4-dimethyl. So it means we have a methyl group in the second carbon atom, which is this one, and another methyl group in the fourth carbon atom. So this is the structure of 3-ethyl 2,4-dimethylhexane. So first, you need to draw the longest carbon chain before you add the alkyl groups. Okay, so B, you are asked to name the following compounds, all of which have the molecular formula CCH14. So A, to name this compound, you count the longest carbon chain, 1, 2, 3, 4, 5, 6. So 6 means 6 carbon atoms. So the name of this compound is hexane. So it's a simple one, hexane with single bonds. B, you count the longest carbon chain, 1, 2, 3, 4, 5. So it is pentane, but you have a methyl group in the second carbon atom, so the name is 2-methylpentane. Notice that when you are numbering this compound, you have to start from the left-hand side to number, because this is the only side that will give this methyl group the lowest possible number. So if you start from the left-hand side, it will be 1, 2, 3, 4, 5. So it will be 2-methyl. But if you had started from the right-hand side, it would be 1, 2, 3, 4. It would have been 4-methylpentane. So this compound is not 4-methylpentane, but it is 2-methylpentane. You always have to number from the side that will give the methyl group the lowest possible number. So let's have a look at C. So first you count the longest carbon chain, 1, 2, 3, 4. So it is butane, but you have a methyl group in the second carbon atom and another methyl group in the third carbon atom. So the name of this compound is 2,3-dimethylbutane. So D, you count the longest carbon chain, which is 1, 2, 3, 4, 5. So pentane. And if you number it from left hand side is 1, 2, 3. Even if you number it from the right hand side, this carbon atom is also the third carbon atom. So it doesn't really matter the side you start to number, because in either way it will give the same number to this carbon that has the methyl group. So the name of this compound is 3-methyl pentane. So for E, we count the longest carbon chain, 1, 2, 3, 4. So it is butane. And we have a methyl group in the second carbon atom and another one in the second carbon atom. So the name of this compound is 2,2-dimethyl butane. So it cannot be 3,3-dimethyl butane. For instance, if you decide to start numbering from this right hand side, it will give you 3,3-dimethyl butane, but this is wrong because you always have to start numbering from the side that gives the methyl group the lowest number, and that side is from the left hand side. So the name of this compound is 2,2-dimethyl butane. So now we look at cycloalkanes. You are asked to draw the structures for the following compounds. A is cyclobutane. So butane is 4 carbon atoms. So you write 4 carbon atoms. Because it is cyclo, you need to join them to be in cyclic form. So this is the structure of your cyclobutane. The next one is cyclopentane. So pentane, 5 carbon atoms. So you write 5 carbon atoms and then you join them with single bonds and you complete the rest with hydrogen atoms. So this is your cyclopentane. So whenever you are asked to draw any cyclo compound, it means that it must be in cyclic form, in form of a ring. The next one is 1,3-dimethyl cyclohexane. So hexane, 6 carbon atoms. So you write 6 carbon atoms. Remember, there are carbon atoms here, 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 here. So 6 carbon atoms. And then you are asked to draw 1,3-dimethyl. So you add methyl group in the first carbon. This is the second carbon, and this is the third carbon. So 1,3-dimethyl cyclohexane. So it doesn't matter which side you add the methyl groups, you can decide to number it this way. It is still 1, 2, 3. So both are correct. So 2B, you are asked to name these compounds. So you can see here it has 3 carbon atoms, so it is propane. Because it is in cyclic form, it is cyclopropane. And this is methyl cyclopentane because it has 5 carbon atoms. There's 1 here, 2, 3, 4, 5. And because of this methyl group, it is methyl cyclopentane. Okay, now we look at alkanes. You are asked to draw the structures for the following compounds. I is butane. So butane means that there are 4 carbon atoms, and ene means that there is a double bond. These two means that the double bond is in the second carbon atom. So this is the structure of butane. So if you number it 1, 2, the double bond is in the second carbon atom. So you are asked to draw the structure for 2-methyl butane. So you draw your butane, put the double bond in the second carbon atom, and then you put your methyl group in the second carbon atom. So this is the structure of 2-methyl butane. So you are asked to draw the structure of 2,3-dimethyl butane. So this is your butane, the longest carbon chain, and then you add a methyl group in the second carbon and another methyl group in the third carbon. So this is the structure for 2,3-dimethyl butane. Right, so you are asked to draw the structure for 3-ethyl 2-methyl pent-1-ene. So the longest carbon chain is pent-1-ene. So pent means 5 carbon atoms, ene means that it is an alkane, and this one means that the double bond is in the first carbon atom. So first you draw 5 carbon atoms and you put the double bond in the first carbon atom. So you're asked to draw 3 ethyl, so you put the ethyl group in the third carbon atom. Remember, you start numbering from the side that will give the double bond the least number. So it will be 1, 2, 3. So you put your ethyl group here. Then 2 methyl, you put your methyl group in the second carbon atom. So this is the structure for 3 ethyl, 2 methyl, pent 1 in. 3b, you are asked to name these compounds. So for I, you count the longest carbon chain, 1, 2, 3. So it is propene because it has a double bond. And because you have a methyl group in the second carbon, it will be 2-methyl propene. For this compound, if you number it, you will have 1, 2, 3, 4, 5. So it is pentene. Because you have the double bond in the second carbon atom, it will be pent 2-ene. And because you have one methyl group in the second carbon atom and another methyl group in the fourth carbon atom, it will be 2,4-dimethyl pent 2-ene. Notice that you cannot start numbering from the right hand side because if you do, it will be 1, 2, 3, 4, 5. So it would have been 2,4-dimethyl pent 3-ene. For this 2,4-dimethyl-pentene is not correct because the double bond has a higher number if you start numbering from the right. But if you start numbering from the left, it will give the double bond a lower number, which is 2-ene. So the correct name for this compound is 2,4-dimethyl-pent-2-ene. So now we look at compounds that contain halogens. You're asked to draw the structures for the following compounds: tetrachloromethane. So methane is 1 carbon. You draw 1 carbon, you add the 4 bonds to it, and then you complete the bonds with chlorine atoms. The next one is 1,1-dichloroethene. So ethene is 2 carbon atoms with a double bond. You draw 2 carbon atoms with double bond. Because you are asked to draw 1,1-dichloro, you put 1 chlorine here and another one here, and then you complete this with hydrogen atoms. So you can either draw it this way or CH2, which is come from this side, double bond, CCl2 from this side. So either this or that is correct. You are asked to draw 1,2-dibromo-2-methylbutane. So butane is the longest carbon chain. So you write it down and then 1,2-dibromo. So it means you have bromine in the first carbon and another bromine in the second carbon. You add that. And then you have 2-methyl in the second carbon. So this is the structure of 1,2-dibromo-2-methylbutane. So IV is 1,2-dibromo-cyclohexane. So cyclohexane, there will be 6 carbon atoms in cyclic form, and 1,2-dibromo, you add the bromine in the first and second carbon atoms. So 4b, you are asked to name these compounds. So for this, you count the longest carbon chain, 1, 2, 3, so that is propane. But you have the iodine in the first carbon atom, so it will be 1-iodopropane. The next one, you count the longest carbon chain, 1, 2, 3, 4, so it will be butane. You have bromine in the second and third carbon atoms, so it will be 2,3-dibromobutane. So di because we have 2 bromine atoms. So the third one, you count the longest carbon chain, 1, 2, 3, 4, 5. So that's pentene. But you have the double bond in the second carbon atom, 1, 2, so it will be pent-2-ene. And we have fluorine in the first carbon, so it will be 1-fluoro. And we have methyl in the second carbon, so it will be 2-methyl-pent-2-ene. So the name of this compound is 1-fluoro from here, 2-methyl from here, methyl pent-2-ene. So to number this compound, you have to start numbering from the right-hand side because that is the side that gives this double bond the least number. If you start from the left-hand side, it will give it 1, 2, 3. But if you start from the right-hand side, it will be 2. So you always follow the side that gives the double bond the least possible number. So now we look at alcohols. You are asked to draw the structures for the following compounds. Ethanol, that's a simple one. So ethanol, 2 carbon atoms and an OH in the first carbon atom. The second one is 2-methyl propan, 2-ol. So propan means 3 carbons and 2-ol means OH in the second carbon atom. 2-methyl means methyl group in the second carbon atom. So this is the structure of 2-methyl propan 2-ol. III, butan 2-ol. So butan 2-ol, butan means 4 carbon atoms, so you draw that and add the hydrogen atoms. So 2-ol means OH in the second carbon atom. So this is the structure of butan 2-ol. So IV, you are asked to draw both 2-ene 1-ol. So this means the longest carbon chain is butene. So you draw 4 carbon atoms. 1-ol means that there is OH in the first carbon. So you add that OH to the first carbon. And but2-ene means that there is a double bond in the second carbon atom. So 1, 2, you put the double bond there. So this is the structure of but2-ene 1-ol. 5b, you are asked to name these compounds. So for this, you count the carbon atoms, 1, 2, 3, 4, 5. So that's pentan. Because OH is in the first carbon, it will be pentan 1-ol. The next one, you count the longest carbon atoms, 1, 2, 3, 4. So that's butan. Because there is OH in the first carbon, is butan 1-ol. And because there is a methyl group in the second carbon atom, so that's 1, 2, it will be 2-methyl butan 1-ol. Notice here, you have to start counting from the side that will give the OH group the least number. If you had started from the left-hand side, it would have been 1, 2, 3, 4. OH would have gotten 4th position, but you do not want that. You want to start counting from the side that will give this OH the least possible number. So that's why you cannot start from the left-hand side to count. So III, you do the same thing. You count from the side that will give this OH the least possible number. So that side is from the right. 1, 2, 3, 4. So the longest carbon chain is butan, and it's 1-ol because OH is in the first carbon atom, and there's a methyl group in the third carbon atom. 1, 2, 3. So this is 3-methyl butan 1-ol. For IV, you count the longest carbon chain, 1, 2, 3. So it will be propan 1-ol. OH is in the first carbon atom, and there is a methyl group in the second one, and there's another methyl group in the second carbon atom. So this will be 2,2-dimethyl propan 1-ol. So always you count from the side that will give the OH the least possible number. So now we look at aldehydes and ketones. So you're asked to draw the structures for the following compounds. So ethanol has 2 carbons, so CC, and you complete the hydrogen atoms. So the functional group for ethanol is C double bond O and a H here. So this is the structure of ethanol. II is butanone. We also call it butan 2-one. So it means there is a double bond in the second carbon atom. So this is the structure of butan 2-one, or you can write it in this form. So there is C double bond O in the second carbon atom. So remember here, you start counting from the side that will give this double bond the least possible number. So you cannot start from left-hand side, you can only start from right-hand side. So III is 2-methyl propanal. So propanal, 3 carbon atoms, and you add the functional group, double bond OH. And then there is a methyl group in the second carbon atom. So you add it here. So this is the structure of 2-methyl propanal. So IV is 2-methyl pentanthreone. So there is a double bond in the 3 carbon, and then there's a methyl group in the second carbon. So this is the structure of 2-methyl pentanthreone. Okay, so 6B, you are asked to name these compounds. So this compound I is methanol because it has one carbon atom and it has C double bond O and H. So this is methanol. This compound here, II, is 3-methyl pentanone because if you start numbering from the left-hand side, 1, 2, 3, 4, 5, the double bond is in the second carbon atom and the methyl group is in the third carbon atom. So the name is 3-methyl pentanone. So you cannot start numbering from the right-hand side because if you do, it will be 1, 2, 3, 4. This double bond O will have number 4 position. So you have to start numbering from the side that will give this double bond the least possible number. And that side can only be from the left-hand side. So the name of this compound is 3-methyl pentanone. III is pentanone. So you have to start numbering from the left-hand side. 1, 2, 3, 4, 5. If you had started numbering from the right-hand side, it would have been 1, 2, 3, 4, 5. It would have given this C double bond O number 4 position. So you always start numbering from the side that will give the double bond the least possible number. So the last one is this compound, and the name is 3,3-dimethyl-butanal. Butanal because the longest carbon chain is 4. 1, 2, 3, 4. And it is an aldehyde because it has C double bond O and H. And there are one methyl group in this carbon and another methyl group in this carbon as well. So it is 3,3-dimethyl-butanal. So this is where we're gonna end for tutorial 1.